Let us go, cabbages. What's this? Cubed root of 108. What's this one? Fourth root of? Yes. You want that test?
Yes, please. Do you have a copy?
Wait, what did you think? Wait, why did I get a different answer? But isn't it 7? Oh, whoa.
And C.
Square root of 875.
Nicely done. 5A.
Square root of 105.
It doesn't change. It's root 105. There's no groups to take out. Why would I put that there? Because you have to know when you can't do math. No. It is 2 times 5 times 7. Or sorry, 3 times 5 times 7. No pairs. What's this guy? 14. We write that. It was on our list. What's this guy? Yeah. What's this guy?
I mean, it's already done.
No, it's not done. It's 3 times 2, 16. So it's 18 cube root 3. What's this one? 'Pardon me? 5 fourth root 6? What? Oh yeah, it's 2. That's not a 3. Dummy head. 2. I gotta check that. That's 125 times 5 is 625. 625 times 6. Yep, that's right. This guy.
What was D?
D was 5 fourth root of 6. What's E? 8 root 6? Okay. 384 divides, I hate doing trees. Divides by 2. That's okay. 192 divides by 2. 96 divides by 2. 48 divides by 2. 24 divides by 2. 12 divides by 2. 6 divides by 2. 3. I need groups of 2. 1, 2, 3 groups of 2. So out comes 2 cubed. 2 cubed is 8. 8 times 6 is 48. And what did I leave under there? 2 times 3, 6. What about this one? Negative 12 root 5. Abso-smurfly correct. How do you do number 6 without your calculator? You could estimate. That's one option. Jasleen? To what? It's already mixed. You could change it to entire, right? So, yes?
For E, what do you do with the 3 and the 2 in the tree?
That's what's left over. You can't take them out. 2 times 3 is 6.
Well, then what was the 6 at the front? What did you
That
do?
was already there.
So what did you do with it?
What do all coefficients do?
Times it?
Multiply. So there was a 6 there, and I brought out another 8. That makes 2 coefficients, 8 and 6. All coefficients multiply together. 8 times 6 is 48. You say that questioningly. What do coefficients do?
You times it by
Right.
whatever's in front.
Right. So, we brought out an 8 because we brought out 3 groups of 2. 2 cubed is 8. There was already a 6 there, so 8 times 6 is 48.
And you just kind of left the 2 and the 3.
Of course you left the 2 and the 3 in there because they do not make a group of 2.
Okay.
So, you could estimate, like Thomas says, that's a lot of work. I like to say, isn't that the square root of 50? Isn't that the square root of 48? Isn't that the square root of 54? Isn't that the square root of 28? And isn't that the square root of 72? Then it becomes real easy to put the smallest one first, right? What's smallest? Root 28, which is 2 root 7. What's next? 4 root 3, because it's 48. 4 root 3. Then what? 5 root 2, because that's 50. Then what? 3 root 6, because that's root 54. And lastly, 6 root 2. Yay! What makes H more difficult? The cubed root. It's already an entire radical. So in this one, you have to do what Thomas said, and you have to do what Jasleen said. You can fix all these. This guy's real easy. It's root 180. What's this guy? Root 52. What's this guy? Root 36. And this guy's 3 root 10. Well, the cube root of 10 is pretty darn close to the cube root of what number? What's a cube that's close to 10? 8. What's the cube root of 8? 2. So this number must be a little bit more than 2, right? Aren't all those bigger than 2? So what's going on the far left of our number line? Cube root 10. What's next? 3 root 4. What's next? 2 root 13. What's next? 6 root 5. Yeah? Yeah. Please notice that the value of these is not anything to do with the value of the coefficients or the values of the radicals singly, right? Yay! How many of you feel you need more practice in cubes and squares? Great, there's a whole page of them on page 129. Let us move on, cabbages. That's practice. Next thing's a quiz. We won't do that today, obviously. Now, please go to page 130. Adding and subtracting radicals is very similar to adding and subtracting variables. You already know how to add and subtract variables, so therefore, you already know how to add and subtract radicals, yes? Of course you do. Let us begin. If I gave you, somebody give me a number between 1 and 100.
7.
Why do they always choose 7? Somebody give me a letter.
A letter.
Now, somebody give me another number.
74.
Now somebody give me a letter. Now somebody give me another number.
36.
And another number.
16.
What would you do if you were in the 9th grade and you were faced with that schmozzle? You would collect like terms, wouldn't you? What would you do with the 7a? I would add it to 21a. Why? Because they are like terms. So I would have 28 A's. What would I do with the W's and the W's? To get what? 90 W's. What if I added this to the mix? It would be plus 17Z. Why? Because there's no other Z's. Okay? Okay. If you know how to do that, You know how to do the next thing. But before we do the next thing, we are going to talk about some terms. What mathematically is this 7? It is a coefficient, right? Excellent. What mathematically is this 21? A coefficient. Excellent. That coefficient of 7 affects what variable? A, which means if I were to draw this out, I would have how many A's? 7. They are not multiplying. I am just counting the A's. That is why it is not a to the 7th. I'm not multiplying. I'm just counting them. Yes? How many A's would I have to draw here? 21 more. So I'd have to draw 21 more, and I would end up with 28 little A's drawn on the page. Yes? Because mathematically, what does this expression mean? 7 times A. There's an A, and I would do it 7 times. Agreed? Okay. What then is that? What is that 7? That is a coefficient. Mathematically, what does that mean? So I would write root 2 how many times? 7. Okay. What then if I added 4 root 3? What would I have to do? I would have to write root 3 how many times? 4 times. So I'd have root 3, root 3, root 3, root 3, root 2, root 2, root 2, root 2, root 2, root 2. Agreed? Is root 3 the same as root 2? No, of course not. So can I add them together? No. What if I brought along to the party 3 more root 3s? What would I write? 3 more root 3s. For an answer of what? 7 root 2s and 7 root 3s. So what's the rule? I can combine like radicands. 3 and 3. Anything new? Not new math, but a new piece of knowledge. If the radicands are the same, they can be added. Yeah? Yeah. So, how easy is that? Easy. How many root 3s do I have? Why is it 3? I only see a 2. Because there's a 1 there. So that is 1 plus 2 root 3, which is 3 root 3. What is B? That's okay. You don't need to see because you can all add 3 plus 5 and it's written on the piece of paper right in front of you. Yeah? What is different in C? There's 2 different things. One, there's subtraction. But we know subtraction's a fake out. Invented by lazy math guys because they were too lazy to write plus minus. So subtraction isn't going to fool us. What else is different in C? There's a different radicand. What can I do with different radicands? Nothing. So what have I got here? Negative 2 root 7s plus root 2. What have I got in D? What's there and there?
6.
The same radicand. So what do I get to do? Combine them to get what? Negative root 6. What have I got there and there? the same radicand, so I get to combine them. What is it? Minus 2 root 3. Is everybody good? That is the only piece of new knowledge. Does that mean we get to forget all of our old knowledge? No, and I even reminded you that you can't forget all your old knowledge with that line right there. Simplify first. Right now, is that addable? Of course not. Why? Because they have different radicands. But, just like in grade 3, would you leave an unsimplified fraction for Mrs. Bad Crumble before you tried to add them? Of course not. So for Mr. Bad Crumble, would you leave unsimplified radicals? Of course not. And what would you get? You would not do the work, and I would have to give you 0, right? So let's do that work. What is this? That is 16 times 2. What is this? 4 times 2. What is the square root of 16? 4 root 2. What is square root of 4? 2 root 2. And what do I get?
6 root 2.
That took a little longer than I was hoping. Have no fear, internet legions of fans. They'll get it. Can I combine the 3 radicals in B? No, of course not. Yet. Why? Because they are unsimplified. Only a fool would leave something complicated that one can make simple. So let us make it simple. What is that? 4 times 7. Mr. Myers, why did you choose 4 instead of doing a factor tree? Because 4 is a perfect square. What is 63? 9 times 7. Mr. Myers, why did you choose 9? Because 9's a perfect square. What about 112? That's 56 times 2, isn't it? Right? Or 4 times 28. 4 times 28. Hey, I know 4. Wait a minute. Isn't 28 4 times 4 times 7? What's the square root of 4? 2 root 7. Minus, what's the square root of 9? 3 root 7. Plus, what's the square root of 4? 2. And then another 4. 2. So I brought out 2 2's. What happens then? They become 4. What did I leave under there? 7. What is 2 minus 3? What is negative 1 plus 4? 3 root 7's. Complicated? No. Fussy? Yeah. Persnickety? Yeah. And that is a real word, so don't all get mad at me. Persnickety is a wonderful word. Use it 3 times a day and it's yours forever. It means overly fussy. Much like all of you when you were like 5 and wouldn't eat food. Huh? You're a liar. No. All parents think their kids aren't picky eaters because they give their kids what they want so they don't have to fight.
No, actually, I eat everything. Oh, Jesus.
That sounds like a lie, but I will choose to believe you. If I gave you a plate of Brussels sprouts, you'd be like, yeah, hells yeah. Give me more Brussels sprouts. You're a liar. Because they're disgusting. Yes, they are. That's all right. Turn the page over. Hey, that looks awfully familiar, doesn't it?
Oh my gosh.
Doesn't C look very similar to B? Except there's already coefficients out front. Does anything change? No. We know that was 4 times 7. We know that was 9 times 7. And we know that was 16 times 7. What's the square root of 4? 2. So what comes out? What was already there? So what do we got? 10 root 7s. What's the square root of 9? 3. So what comes out? What was already there? So what do we got? 9 root 7. What's square root of 16? So what comes out? Well, we already got. So what do we get? What's 10 minus 9? What's 1 plus 8? 9 root 7. All in your head. Didn't even write it down. Crazy doing math in my head. That's where math is done. No, math is done in your head. Watch. I just put my pen down. Any math getting done? No. Math gets done in your head. Uh-oh, Mr. Myers. What the halibut are you trying to pull here? Of course it doesn't change anything, Thomas. Why doesn't it change anything? Because math makes sense. And it always is the same. What is the square root of 4 times c? 2 root c. What is the square root of 9c? Out will come a 3. What was already there? 4. So what's the answer? Negative 12 root c. Are those radicands the same? Damn Skippy. What's 2 minus 12? Negative 10 root c. C, not 3, you idiot. Boy, math is hard. I don't know how anybody gets it. I mean, you only do the same thing over and over. My wife and I were discussing this last night. We were trying to discuss, because we were trying to do chemistry with my son. And he was doing some combining of elements, which you all did in the 9th grade. And of course you know that if sodium, Na, is a 1, and chlorine is a 1, you just cross the numbers to get NaCl. How many times have you practiced that? Many. How many times do you need to practice it? Once. Because if it works once, how often does it work? Always. So, yeah. So if you do it once, should you have any trouble if it is, say, beryllium 2 and, let's say, fluorine 1. Is it complicated? No, what is it? BeF2. Done. But my kid, oh no. Just like you guys with math. So I was trying to talk to my wife and say, why is it that they don't get it? Why is it that they do a question, then the very next question, they're like, I don't know what to do. And we've come up with a reason. We know the reason. Because back in the day, when your parents went to school, we still used textbooks. Textbooks weren't evil. Worksheets weren't evil. Before you were allowed to go further, you practiced every single thing 1,000 times on a worksheet. I know. I do too. The only difference between you people, whose brains are all mushed up by puberty, and my brain, when I was your age, and my brain was all mushed up by puberty, is we didn't have any technology. We had to use textbooks. And when you did A through Q 25 times, all of a sudden you knew how to do stuff. But the experts in education say that's bad pedagogy. You shouldn't do that. Pedagogy is the science of teaching. Like biology is the science of life. Of course there's a science of teaching. You think we just get up here and wing it? Huh? Yes. Which would be, now, everyone says yes, but sitting down and making a kid do 300 questions, if they get it after 5, that's barbaric. You shouldn't do that. Fine. Which is exactly what I do in this room, isn't it? Except, as soon as I say, you don't have to do all of it, do it till you're comfortable. None of you do any of it. And the very next question, I know how to do that one. If I said do every single question, you'd all know how to do the questions. But then, that's bad pedagogy. Except, all the research proves that that is the best way to teach math. It's not the best way to teach much of anything else, but it's the best way to teach math. But because it's the best way to teach everything else, like everything in education, when you throw out the bathwater, you throw out the baby with it. So because projects and things are better for everything else, they decided projects and things are better for math too. Even though all the research in the world says it's not. Why would they? Math works when you see how to do it and you practice it. That's what works for math. Doesn't work for English. You can read all the essays in the world. It's not going to make you write a good essay. Right? You got to actually practice it. In math, how do I get you a project to figure that out? How can you practice that in any way other than doing it? Right? So, this question is almost impossible. Go. What? Mr. Myers bringing old math back to get us? You son of a... Go. What? No, that x says this whole distance is x. I want to know what it is exactly. So, have fun. I ever not give you an explanation, Suhani? True, when you don't ask. All right. A bunch of you noticed that there are right angle triangles here, which means you probably need to do trig. Which means on this side you have a theta, which equaled 30, and you had an opposite, which equaled 40, right? Right? Now, you could have done something here, correct? You could have done tan, yeah? And that would have given you your adjacent equaled this part of x. So let's call that p. Your adjacent was p. So it would have been what? Tan theta equaled opposite 40 over p, yes? Which would have been 40 over tan 30. Yeah? Okay. That's one thing you could have done. Why is that a bad idea? Tan 30 is not an exact number, is it? We know that it's an exact number sooner or later. But what does it appear as on your calculator? Irrational. So that was a bad idea. What else can I do with a theta of 30 and an opposite of 40? Jasleen, could you find that? How? Not yet. Sine hypotenuse equals, let's call that one P now. So, sine of 30 equals opposite 40 over P. 40 over sine 30 equals P. And when you do that math, what do you get? 80. Hey, that's a pretty exact number. That makes me happy. Hey, wait a minute. Isn't this the same thing? So what should I do? Same thing. 30 over sine 30 equaled what? 60. Now I have this triangle with 80 and 40. And I have this triangle with 30 and 60. What finds me that?
Wait, so the only reason why you didn't do the bottom one first is for the adjacent is because it wasn't exact.
You could have, right? If you guys knew a little bit more about trig, you could have done this with the first one. So this blue side is what? The square root of what? 80? No. 80 squared minus, no, 40 squared. That got you the blue because 80, 40. And what got you the pink? Plus the root of 60 squared minus 30 squared. And that got you the pink one. What is 80 squared? What's 6,400? Minus, what's 40 squared? 1,600. Plus, what's 60 squared? Minus 30 squared. What's 6,400 minus 1,600? This is my favorite. 4,800. Plus, what is 3,600 minus 900? 2,700. Isn't that 48 times 100? And isn't 48 3 times 16 times 100? Why did I choose 16 and 100? Because they're perfect squares. Isn't this 27 times 100? And isn't 27 3 times 9 times 100? Why did I choose 9 and 100? Perfect squares. What's the square root of 16? 4. So what comes out here? 4. What's the square root of 100? So what comes out here? They're now what? Coefficients. So they are 40 root 3's. Plus, what's the square root of 9? 3. So what comes out? 3. What's the square root of 100? So what comes out? 10. They're now what? 30 root 3. What is 40 root 3's? And then 30 more root 3's. 70 root 3's. Now, the question becomes, as always, was there any piece of new information there? Nothing. Not one thing there was new. Even adding radicals wasn't really new, was it? Because you all already knew how to add coefficients and the thing they multiply. Right? Awesome, possums. All right, now, we did a whole bunch of work on easy simplifying of radicals. If you are uncomfortable with that, there is a page of practice in your book. Where did I take that page from? A textbook, which means it has what? Lots and lots of practice on it. Are the answers there? If you do every single question on there, will you have a very good understanding of simplifying radicals? How many of you are going to do every question? Okay. This page, which is page 129, has all kinds of practicing on it. I would recommend doing all of it, as I always recommend doing all of it. Do I believe that any of you are going to do all of it? No. Which is why I give you the option of doing as much as you see fit. However, if you only do as much as you see fit, and then you don't get 100% on your tests, did you do enough? No. We have had 3 unit tests. If you haven't got 100% on all 3 of them, not the cumulatives, the unit tests, then have you been doing enough practice? No. So, if you repeat your behavior from the first 3 units, what will happen on this unit? The same thing. Now, you will notice that after that triangle question, I have left a big blank page that says, if I'm not mistaken, practice addition and subtraction of radicals in one of my favorite fonts, Blush Bear, because I like the little bow.
It's a different font.
What?
We don't have that.
What do you guys have?
I like it.
It's a really boring.
Horse crap. Well, feast your eyes on Blush Bear. Isn't it beautiful? They're little bows. Look. Just wait. You guys, you're so high maintenance.
Oh my goodness.
Yes.
What does it have to do with bears?
I don't know. I didn't name the font. I just liked it. Blush Bear. This page is blank because I don't yet know where your deficiencies lie. Are you poor at simplifying things like this? Or are you poor at gathering your like terms? So what we need to do before we can practice this page is we have to be very good at this, which you will find on page 129, I believe. Okay? So go do a bunch of work on page 129, and then while you're doing that, I think it's 129, is it? Yeah. While you're doing that, I'm going to write a few slightly more difficult questions than the notes. And then you can try them. And if you all kick all of their butts, I'll write a few slightly more difficult than the slightly more difficult than the notes ones. And then, what will I do? Write a few slightly more difficult than the slightly more difficult than the slightly more difficult to the notes. Aye? Go.
And then?
No more and then.